Fine. That means what? This is my desired reaction and this is my undesired reaction, which I am not at all required. I am not at all interested. I am interested in this compound. But I am getting this compound if more amount of oxygen available. Now, sometimes it is highly difficult to control the oxygen because oxygen is readily available in the atmosphere. So, in some of the reactors, they control the oxygen flow rate. But somehow what will happen? If small amount of oxygen is available, little bit more than the required in the stoichiometric ratio, instead of forming of lithium oxide, you will get carbon dioxide, which is undesired. That means what? The same compound, if I write like this. The same compound A, giving a product called ethylene oxide, maybe some important compound called R, this desired one, which is desired one. I may lead to some other component from the same component A, which is undesired. These are called parallel reactions. Parallelly, same component is giving one component, same component is giving other component. Parallelly, the reactions will go on. It's called parallel reactions. A giving rise R, A giving rise is called parallel reaction. Component reactant is A only. But what is happening? The products, sometimes you may get a product called R, which is the desired one. Sometimes you may get a product called S, which is undesired one. The best example. I want only the desired component. I do not want undesired component. Now, how I can manipulate it? You tell me. So the reason I told you is supply of oxygen. The reason I told you is supply of oxygen. If I give the stoichiometric ratio of oxygen to the ethylene, I will get the desired component. But let us suppose I am unable or I am uncontrolled of supplying oxygen. Uncontrolled of supplying oxygen. What will happen? I will not get this. I will get this only, undesired only. But I want to get the desired component only. How I do? Yes. How do I improve the rate constant? Because see, this is one rate constant, this is another rate constant. What is the rate constant definition I told you? The rate constant definition is the rate at unit molar concentration. The definition. That means the rate. If I increase the K1, the rate is increases. The rate increase means the rate of formation of this is increases. Is it not? So I should focus on how to increase the reaction rate of K1 only, not K2. Is it not the one way? Because the first way is control the oxygen. If it is not in my hand, I cannot control the oxygen. Then the second way is improve the K1 rate. Improve the reaction rate constant. Don't touch K2. If I increase the reaction rate constant K1, definitely I will increase the desired product. Now how to increase the reaction rate constant K1? I will look at any catalyst available for this reaction. What is the role of catalyst? I told you. What is the role of catalyst? Without participating in the reaction. So for this reaction, if I could see any catalyst is working, I introduce the catalyst which favors this reaction only but not. So silver is a better catalyst, silver is a good catalyst for this reaction. So what I do? I simply introduce silver into the reactor. This catalyst will work on this reaction but not this. What will happen? The reaction rates will improve. What will happen? The desired product is improved. So though the reaction is parallel only, but the desired component is increasing rather than the undesired. Is it clear? The concept? So why we want parallel, why we want series reactions, I will explain you later part. But parallel reaction, let us start. So A gives rise R, A gives rise S. These parallel reactions, let us take rate constant K1, let us take rate constant K2. Now this parallel reaction is going in a batch reactor. Because we are discussing the batch reactor, I told you we are discussing the batch reactor. What is the batch reactor? Batch reactor is a container which holds the reactants. For some time the reaction will go on. There is no inflow, there is no outflow. It's a batch. It differs from continuous flow reactors where continuous flow of reactants, continuous flow of products will be there. But batch reactor, there is no inflow, there is no outflow. Simply it's a container. Best example is whatever you take the beaker in your lab experiments. Beaker, you take the reactants, you close the lid and you try to allow the reaction to happen for some time. It's a batch. Now in the batch reaction, let us suppose these parallel reactions are going on. How do you analyze the kinetics? So now what is parallel reaction? You understood now. Parallel reaction is a one wherein the reactants are yielding desired as well as undesired products. A gives rise or A gives rise yes. Reactant is A only, leading to either or, leading to either S, depending on the rate constant. If rate constant K1 is more, R is formed. If rate constant K2 is more, S is formed. Now let us analyze the kinetics. Because we know for batch reactor, constant volume case minus RA is equal to minus dCA by dt. Is it not? Batch reactor for constant volume case only. Remember we are doing only volume case. I have not changed the variable volume. Still we are in the constant volume case. So minus RA is equal to minus dCA by dt. Now can you write minus RA for this reaction 1 and this reaction 2? First reaction K1 Ca. Second reaction K2 Ca. So overall K1 Ca plus K2 Ca. So K1 plus K2 into Ca. Sorry, I am writing. Minus RA minus dC by dt. K1 Ca. For same A. This is also reaction. This is also having some rate. So for this reaction, what is the rate? Minus RA is equal to minus dC by dt is equal to K2 Ca. So overall, what is the rate of A? K1 plus K1 Ca plus K2 Ca. That means K1 plus K2 Ca. So minus dCA by dt is equal to A1 plus A2 into Ca. Can I do integral analysis? Can I do integral analysis? And apply it then. Integration. Integration of minus dCA by Ca is equal to K1 plus K2 into integral dt. So keep the time limits Ca naught to Ca 0 to t. Now you can do the expression, final expression. Minus minus ln Ca by Ca naught is equal to K1 plus K2 into t. So this is one expression. Now what is R and what is RS? What is R? How I write rate of R? Yes. Plus or minus? Plus. Very good. Not K. Look at K1. K1. Here. That's it. Here. R. What is our usual convention? Usual convention is we always should write in terms of concentration of reactants only. But here the reactants is forming both R, both S. When I want to write product R concentration, rate of formation of R or rate of formation of S, I write in terms of products. I write in terms of product because here the reactant is same giving both the products. I cannot write in terms of concentration. Usual convention is always write in terms of reactant concentration only. But here the reactant is same, but products are different. So I am writing specifically the product R. RR is equal to plus K1 CR. RS is equal to plus CS. Now what is RR? dCr by dt. Is it RR? Is it not RR? dCr by dt. What is RS? dCs by dt. Fine. So if I could integrate it, dCr by CR is equal to K1 into T. Similarly, dCs by CS integration of K2 into T. Or what I do is RR by RS is equal to K1 by K2. K1 by K2. Do integration. Check for the final answer. Do integration. Parallel reactions. But even then, we can consider the same general convention. What is general convention? In terms of concentration of A only. So here also mentioned in terms of concentration of reactants only. So what will happen if I do RR by RS? RR by RS is equal to K1 by K2. This will be cancelled. Now what is RR? RR is dCr by dt. Fine. What is RR? RR is dCr by dt. Fine. RS is dCs by dt. Is it not? Fine. Now we apply the integration. I'll tell you the limits. RR by RS is equal to K1 by K2 or dCr by ds is equal to, if I divide dCr by dt by dCs by dt will be get cancelled. So what is left? dCr by dCs is equal to, yes, dCr by ds is equal to K1 by K2. Now you apply the limits here. Maybe I can say dCr integration is equal to K1 by K2 into integral dCs. Let us apply CS 0 to CS, CR 0 to CR. Product initial concentration final, product initial concentration product. So what will happen? I will end up with expression called CR minus CR naught. Yeah, CR minus CR naught by CS minus CS naught is equal to K1 by K2. Is it okay? CS by CS naught and not on. Now just look at the plots now. What is the first equation plot? If I do manipulation here, what is the first equation plot? If I draw minus ln CA by CA naught, minus ln CA by CA naught, if I plot versus P, I'll get a straight line which is slope as K1 plus K2. Now if I plot CR versus CS, I'll end up with a straight line. Fine. With the slope equal to K1 by K2. If I plot CR versus CS, I end up with a slope equal to K1 by K2. Now for this parallel reaction, the problem how they frame is, see what I'm getting from the first equation. What is the plot I'm getting? If I plot minus ln CA by CA naught versus P, I'm getting slope is equal to. So remember, I'm getting K1 plus K2 value from the slope of first graph. Now look at the second graph. If I plot CR versus CS, I'm getting again a curve with slope is equal to K1 by K2. So from the second graph slope, I'm getting K1 by K2. Can you get K1 K2 from these two values? From you get K1 and K2 for the parallel reactions. They give you the data. They give you the data. Only you have to plot it. Get the slope from here. Get the slope from here. From these two slopes, estimate K1 Is it clear? So understand the importance of parallel reaction. Parallel reactions are those which lead to desired component as well as undesired component depending on the rate constants. So the reactant is A only. Sometimes you may get R, sometimes you may get S. How to trigger? If I want only desired component, I should increase the rate constant of the K1 only because I want desired component. How I increase the rate constant? I introduce a catalyst. Right? Now what is the analysis? I should plot minus LNCA by CA naught versus T so that I'll get a slope called K1 plus K2. I have to plot CR versus CS so that I'll get a straight line slope K1 by K2. From the values of K1 by K2 and K1 plus K2, I'll get individual values of K1 and K2. Clear? So we do one problem so that you'll analyze. Before that, yesterday I have seen one important problem. We will check that problem. Yeah, the partial pressure of azomethane partial pressure of azomethane that is CH3 N2CH3. The partial pressure of azomethane CH3 N2CH3 was observed as a function of time. Was observed as a function of time. As shown below. So the reaction is azomethane. So CH3 N2CH3 gives rise CH3 CH3 plus N2. So time, then partial pressure. Partial pressure in torque, units of torque or mmHg. The value is 0, 820, 1000, 572, 2000, 399, 3000, 278, 4000, 194. This is the data given. Determine the order and rate constant. Determine the order and rate constant. Yes. Go through the problem. So there is some decomposition reaction. He has given data of time versus partial pressure. If let us say, if he is not given partial pressure, let us say he has given time versus concentration. How do you proceed? If graph is not given, if graph is not given, yesterday we have done some problems, no? So if graph is not given, simple way of analyzing is assume some first order, check whether your k is constant over the intervals what is given. Provided if you get time versus concentration data. Is it not? The previous problem what you have done? We know in the previous problem CA naught, that is at time t0, time equal to 0, we got CA value, that is CA naught, and then CA values. So CA known, CA not known, first order if you assume minus ln CA by C naught is equal to K into T, T known. So you have estimated K, you have estimated K, you have estimated K, and all the K's are almost constant, means the assumed order is correct. That's what we proceeded. Now what is the difference with the previous problem and the problem I asked now? No, you might know the conversion of partial pressure to concentration. Don't you know the conversion of partial pressure to concentration? Concentration is equal to partial pressure by R into T. CA is equal to PA by RT. That's the basic equation. Is it not? CA is equal to PA by RT. CA is equal to PA by RT. So this is the basic equation you know. So partial pressures are known means indirectly you know the concentration. Because if you divide with R and T, you will get concentration value. Wait a minute, wait a minute. See, why you are not thinking? Why you are not thinking? See, if I assume first order, what is my expression? If I assume first order, what is my expression? Is it not my expression? Wait a minute. If you know the expression, I told you CA is equal to PA by RT. CA naught is equal to PA naught by. Is it not RT getting cancelled here itself? That means what? My expression of minus ln CA by CA naught will become minus ln PA by PA naught. So PA naught I know, PA naught at time 0 PA naught I know, PA values I know. What else is required? P is known, conjugate K. So it's just simple manipulation, nothing else. Either concentrations or partial pressures, more or less same for the problem. Now estimate. అర్థమైందా బాబు? పార్సల్ ప్రెజర్ ఇచ్చి జస్ట్ చిన్న మాట్లాడారు ఏం లేదు, పార్సల్ ప్రెజర్ కానీ ఈ ఆర్డర్ని డివైడ్ చేయాల్సిన అవసరం లేదు, ఎందుకంటే ఎక్స్ప్రెషన్ ఆఫ్ డివైడ్ చేసి చెప్పండి. సో K వాల్యూ చూడండి. నెక్స్ట్ వాల్యూ చెక్ చేయండి. సేమా? సో ఫస్ట్ ఆర్డర్ సేమ్ వచ్చిందంటే ఫస్ట్ ఆర్డర్ వచ్చిందా? సో ఫస్ట్ ఆర్డర్ సరిపోయింది కదా? నౌ వాట్ ఈస్ ద రేట్ ఎక్స్ప్రెషన్? వాట్ ఈస్ ద రేట్ ఎక్స్ప్రెషన్? మళ్ళీ what is K? ఒక్క నిమిషం. అన్ని 3.6 లు వచ్చాయా? ష్యూరా? ఒక్కొక్క డిజిట్ ఎక్కడైనా మారుతుంది. అప్పుడు మీరు ఏం చేయాలి? అంటే ఫర్ ఎగ్జాంపుల్ ఫస్ట్ వాల్యూ 3.6 వచ్చింది. రెండో వాల్యూ 3.6 పక్కన 2 వచ్చింది. మూడో వాల్యూ 3.6 పక్కన 5 వచ్చింది. అప్పుడు ఏం చేయాలి? ఈ లెంత్ కలిపి యావరేజ్ వాల్యూ చేయాలి. అంటే అన్ని కలిపి బై 3 ఉంటే బై 3, 4 ఉంటే బై 4. అట్లా చేసి ఆ వాల్యూ చేయాలి. యూ హావ్ టు టేక్ ది యావరేజ్ వాల్యూ. అన్ని 3.6 లో వచ్చింది అనుకోండి, యావరేజ్ చేస్తే 3.6 వస్తుంది. మీరు చేయాల్సిన అవసరం లేదు. అంతే కదా? కొంచెం వేరియేషన్ ఏమైనా వస్తే యావరేజ్ చేసి వేయాలి. సో యావరేజ్ కే మల్టిప్లైడ్ బై కాన్సంట్రేషన్ ఆఫ్ CH3 పవర్ 1. ఓకేనా? Right? Hold on. The half-life period for decomposition of pH3 of P for decomposition of pH3 is given below. The half-life periods for decomposition of pH3 at different initial pressures are given below. Determine the order of the reaction. In terms of time, T half in terms of minutes. అంతే పేజీలు వెనక్కి తిప్పుకోవడమే. అంతే కదా? చూడండి, టీ హాఫ్ ఏమీ మారలేదు. మనకి టీ హాఫ్ ఎక్స్ప్రెషన్ తెలుసు. ఏంటి టీ హాఫ్ ఎక్స్ప్రెషన్? కానీ ఇక్కడ కాన్సన్ట్రేషన్ ఇవ్వలేదుగా. ప్రెజర్ బై ఆర్టీ అంటే కాన్సన్ట్రేషనే కదా. అంటే అర్థం ఏంటి? పార్షియల్ ప్రెజర్ మారుతుంది అంటే కాన్సన్ట్రేషన్ మారుతున్నట్లే కదా. కాన్సన్ట్రేషన్ మారుతుంది కానీ టీ హాఫ్ మారట్లేదు కదా. ఇంకా ప్రాబ్లం చేయాల్సిన అవసరం ఏముంది? ఇస్ ఇట్ ఓకే? బట్ రియల్గా అటెంప్ట్ చేసి మీరు ఫస్ట్ ఆర్డర్ ప్రూవ్ చేయాలంటే ఏం చేయాలి? టీ హాఫ్ ప్రపోర్షనల్ టు సిఏ నాట్ పవర్ 1 మైనస్ అని ఎక్స్ప్రెషన్ తెలుసు. అందులో సిఏ నాట్ బదులు పిఏ నాట్ బై ఆర్టీ వేసుకోండి. వేసి రెండు కేసెస్కి రెండు వాల్యూస్ వేయండి, సాల్వ్ చేయండి, ఎన్ 1 వచ్చేస్తుంది. ప్రూవ్ చేయమంటే చేయాల్సిన పద్ధతి ఆల్రెడీ చేసాం కూడా మనం. క్లియర్, అర్థమైందా? లేదు ప్రూవ్ చేయాల్సిన లేదా కానీ చూడగానే గేట్ ఎగ్జామ్లో పడగానే టప్మని కొట్టేయచ్చు 1 అని, ఎందుకని చూస్తేనే అర్థమైపోతుంది. టీ హాఫ్ అసలు మారట్లేదు, ఎంత మార్చినా మీరు పీలు కానీ సీలు కానీ. పి అంటే ఏంటి? సిఏ. అర్థమవుతుందా? In case of a first order reaction, show that the time required for 75% conversion in case of a first order reaction, show that the time required for 75% conversion is double the time required for 50% conversion. The time required for 75% conversion is double the time required for 50% conversion. ఎక్స్ప్రెషన్ కూడా మర్చిపోయినారు. నౌ వాట్ యు వాంట్ టు ప్రూవ్, ఆల్రెడీ ప్రూవ్ చేయమంటున్నాడు. ప్రాబ్లమ్ లోనే ఆన్సర్ ఇచ్చేసాడు. షో దట్ అంటున్నాడు. ద టైమ్ రిక్వైర్డ్ ఫర్ 75% కన్వర్షన్ ఈజ్ డబుల్ ద టైమ్ రిక్వైర్డ్ ఫర్ 50% కన్వర్షన్. ఓకే, అంటే ఫస్ట్ ఏం చేయాలి? 75% కన్వర్షన్ కి టైం కట్టండి, పక్కన పెట్టుకోండి. 50% కన్వర్షన్ కి టైం కట్టండి. ఇప్పుడు రెండు టైంని చూడండి, డబుల్ అయిందా లేదో మీకు అర్థమవుతుంది. చేయండి. చాలా మంది ఎందుకో తప్పులు చేస్తున్నారు. స్మాల్ టీ అంటే టైం, క్యాపిటల్ టీ అంటే టెంపరేచర్. స్మాల్ టీ అంటే పార్షియల్ ప్రెషర్, క్యాపిటల్ టీ అంటే టోటల్ ప్రెషర్. స్మాల్ కే అంటే రేట్ కాన్స్టెంట్, క్యాపిటల్ కే అంటే ఈక్విలిబ్రియం కాన్స్టెంట్. స్మాల్ ఎక్స్ అంటే మోల్ ఫ్రాక్షన్, క్యాపిటల్ ఎక్స్ అంటే కన్వర్షన్. అన్ని సేమే. న్యూమరికల్ లెటర్స్ లో స్మాల్ క్యాపిటల్ డిఫరెన్సెస్ ఉన్నాయి. కెమికల్ ఇంజనీరింగ్ లో డిఫరెన్సెస్ ఉన్నాయి, కన్ఫ్యూజ్ అవ్వకండి. మొన్న కూడా ఎక్సే రాస్తున్నారు, స్మాల్ ఎక్సే రాయకూడదు, క్యాపిటల్ ఎక్సే రాయాలి. క్లారిటీ ఉంటుందా? స్మాల్ ఎక్స్ అంటే ఏంటి, క్యాపిటల్ ఎక్స్ అంటే ఏంటి, స్మాల్ టీ అంటే ఏంటి, క్యాపిటల్ టీ అంటే ఏంటి. టీ బదులు ఇది రాశారనుకో టెంపరేచర్ అయిపోతుంది, టైం అవ్వదు. కైనెటిక్స్ లో టైం ఇంపార్టెంట్. చెప్పండి సరిపోయిందా? షో దట్ సరిపోయిందా? ఎక్స్ప్రెషన్ ఏమొచ్చిందమ్మా చెప్పు తల్లి. మాధురి మాధురియా మాధురి ఏమ్మా T1 ఎంత వచ్చింది ఎక్స్ప్రెషన్ చెప్పు. వెరీ గుడ్. 1 పాయింట్ నిమిషం. T1 ఎంతమ్మా? 1.3. వెరీ గుడ్. T2 ఎంత వచ్చిందమ్మా? ఓకేనా? సో ఇది డబుల్ దాన్ దిస్. yes sir. So 2 times of T1 అదే ప్రూవ్ చేయమన్నాడు. సో ఇది చూడండి, ఇది ప్రూవ్ చేయమన్నాడు. ప్రూవ్ చేయమన్నాడు. ఫస్ట్ ఆర్డర్ కి ఇది సేమ్ అవుతుందంటే ఇది మైండ్ లోకి వచ్చారు మీరు. ఫస్ట్ ఆర్డర్ అయినప్పుడు 75% కన్వర్షన్ కి ఎంత టైం ఉంటుందో 50% కి డబుల్ అవుతుంది అనేది మైండ్ లో ఉంటే గేట్ లో కూడా క్వశ్చన్ అడగగానే టిక్ పెట్టవచ్చు, మీరు ప్రాబ్లం చేయాల్సిన అవసరం లేదు. ఎందుకంటే ఒకసారి మనం ఆల్రెడీ అటెంప్ట్ చేసాం. ఒకసారి ప్రాబ్లం చేసామంటే మైండ్ లో క్యాప్చర్ అయిపోవాలి, ఇంప్రింట్ అయిపోవాలి. ఫస్ట్ ఆర్డర్ మాత్రమే ఈ స్టేట్మెంట్ వర్తిస్తుంది. ఫస్ట్ ఆర్డర్ n = 1 అయితేనే ఇది సరిపోద్ది. సో నేను ఇప్పుడు ఆబ్జెక్టివ్ టైప్ క్వశ్చన్ లో రేపు ఎగ్జామ్ రాసినప్పుడు ఈ క్వశ్చన్ ఇస్తే 75% కన్వర్షన్ కి 50% కన్వర్షన్ కి రిలేషన్ అడిగితే T1 = T1 అనే క్లారిటీ మీరు రాసేసేయాలి. ఎప్పుడు ఇది అప్లికబుల్ ఫర్ ఓన్లీ ఫస్ట్ ఆర్డర్. క్లియరా? ఎందుకు? ఆల్రెడీ చేసాం ప్రాబ్లం క్లాస్ రూమ్ లో. ఈ మాత్రం గుర్తుపెట్టుకోవడం ఇంకెందుకు మనం. ఓకే నెక్స్ట్. The rates of reaction at concentrations, the rates of reaction at concentrations 0.15 mole per liter, and 0.05 moles per liter or 2.7 into 10 power minus 3, 2.7 into 10 power minus 3 and 0.3 into 10 power minus 3 moles per liter minute. This is also moles per liter minute. The rates of reaction at concentrations 0.15 moles per liter and 0.05 moles per liter are 2.7 to 10 power minus 3, 0.3 to 10 power minus 3 moles per liter minute. What is the order of the reaction with respect to reactant? What is the order of the reaction with respect to reactant? Read the problem carefully. How do you proceed? What is given? What is asking? What is given? The rates of reaction at different concentrations. That means Ca1 given, Ca1 of second value given. Two Cas given, two rates given. He is asking the order of the reaction. So if we don't know the rate, how do we proceed? Simple rate expression, minus R is equal to K into Ca power n. We don't know n. So 2 Ra values, 2 Ca values. Can't you divide to get n? That's all. Two rate values given, two concentrations given. We know if we don't know any rate expression, we always write minus R is equal to K into Ca power n, because we don't know n. So for first Ra1 value given, second Ra1 value given, first Ca1 value given, second Ca1 value given, just divide it one by one, you will get n. Okay, fine. How much order you got? Second order. Good. So the next question. Liquid A decomposes by first order kinetics. Liquid A decomposes by first order kinetics in a batch reactor. In a batch reactor, 50% of A is converted in 5 minutes. Liquid A decomposed by first order kinetics in a batch reactor, 50% of A is converted in 5 minutes. How long will it take to reach 75% conversion? How? Very sharp. Very good. Huh? So if you don't know the expression, how do you proceed? Let's suppose you don't know the expression. How you proceed? Okay. Yes. Fine. So I'm looking for one parallel reaction problem so that we can solve one parallel reaction. Yes, a parallel liquid phase reaction A gives rise R with rate constant K1 and A gives rise S rate constant K2. A gives rise R with the rate constant K1. A gives rise S with rate constant K2. Is going on with K1 is equal to 5 our inverse and K2 is equal to 0.8 hour inverse. K1 is equal to 5 hour inverse. That means 1 by hour. K2 is equal to 0.8 1 by hour. Find the moles of R produced in 15 minutes. Find the moles of R produced in 15 minutes. Given CA0 is equal to 8.5 moles per liter. CR0 is equal to CS0 is equal to 0. Given CA0 is equal to 8.5 moles per liter. CR0 is equal to CS0 is equal to 0. So I explained the concept of parallel reactions. Just try for this problem, okay? You will get it. It's not a big deal. You try for the problem so that we will check in the next class.